Hello dear students, today's topic is standard form of LPP. So firstly we will understand what is standard form of LPP. So given LPP or an LPP is said to be in standard form if following these four conditions are satisfied. So first condition tells us that the objective function must be either in maximization or minimization type. We already seen that in canonical form the objective function should be maximization type, but in standard form this will be either maximization or minimization. Second condition tells us that all constraints must be equations, means we have constraint in an inequality form, so we have to convert that inequality by adding some or subtracting some quantities to make their inequality into equality. Third conditions, equations means we have LHS equals to RHS. Third condition tells us that the RHS of all constraints is non-negative. RHS means this side, means this is numbers, these numbers should be non-negative, means must be greater equal 0. And fourth condition tells us that all decision variables, means that variables we define, let us say x, y, z, etc. These all variables should be non-negative, means all these variables greater equal 0. So I will खूप साऱ्या बुक्समध्ये हे आर्टिफिशियल व्हेरिएबल हे मेन्शन केलेलं नाही आहे ॲट द टाइम ऑफ रायटिंग द स्टँडर्ड फॉर्म. पण जेव्हा आपण सिम्प्लेक्स मेथडने ते एक्झाम्पल सॉल्व करायला जातो तर ते आर्टिफिशियल व्हेरिएबल ॲड करावे लागतात जेणेकरून ते आपले इक्वेशन्स आहेत ते पण त्या सिम्प्लेक्स मेथडमध्ये किंवा सिम्प्लेक्स टेबलमध्ये कन्सिडर व्हावे. सो मी ह्या सगळ्या म्हणजे स्टँडर्ड फॉर्ममध्ये साधं मीन्स 2 मार्क्सला जेव्हा स्टँडर्ड फॉर्म लिहिला येतो तिथे मी आर्टिफिशियल व्हेरिएबल, सरप्लस व्हेरिएबल हे ॲड करणार आहे. सो आय एम टेकिंग ऑल दीज व्हेरिएबल्स ॲट द टाइम ऑफ रायटिंग द स्टँडर्ड फॉर्म. सो टेक एक्झाम्पल ऑफ दिस स्टँडर्ड फॉर्म. So consider first example. Write the standard form of LPP where objective function is maximize z equals to 5x plus 3y subject to constraint. First constraint x plus y less equal to. Second constraint is 5x plus 2y less equal 10. Third constraint is 3x plus 8y less equal 10. With these decision variables means x and y both are greater equal 0. So first condition of standard form tells us that the objective function is either in maximization form or in minimization form. So our function already in maximization form, so we cannot convert this, so we take it as it is. So standard form, standard form of this given LPP. So objective function is maximize z equals to 5x plus 3y subject to. So second condition of standard form tells us that all constraints should be equations or should be in a equality sign. But first constraint is of less equal type, means there is some quantity is less than LHS side. So we add that quantity, means x plus y plus s1, and that s1 is called as a slack variable. So we add this slack variable to make a equality in the LHS and RHS. So when constraint is of less equal type, we add slack variable. Similarly, second constraint is also less equal type. So again we add another slack variable. So 5x plus 2y plus s2 equals to 10. In third constraint, the equality is less equal. So we again add a slack variable. So third constraint becomes 3x plus 8y plus s3 equals to 12 with Now variables are, decision variables are x, y, s1, s2, s3, and all these variables should be greater equal 0. So this is, so we convert this all constant into equation, but this slack variable contributes some quantity in a maximum objective function. So I already mentioned in a table that the slack variable contributes 0 in the objective function. So we add 0 into s1 plus 0 into s2 plus 0 into s3. So this is called as the standard form of given LPP. So we take next example. So in next example we have maximize z equals to 3x plus 5y subject to x plus y less equal 2, and second constraint is 2x plus y greater equal 6, and both the variables are greater equal 0. So for that, firstly we standard form. Firstly we write standard form. So standard form. So first condition is satisfied because our function is already in maximization type. So objective function should remain as it is. So maximize z equals to 3x plus 5y subject to first constraint. First constraint is of less equal type. So we add slack variable to convert that less equal inequality into equations. So we get x plus y plus s1 equals to 2 for second constraint. First second constraint is of greater equal type, means there is a quantity which are greater in a left hand side and less in a right hand side. So we subtract some quantity, so we get a equation or equality sign. For that we subtract, means 2x plus y. In that case we subtract surplus variable, let's say s2, and add artificial variable, let's say a1, and this equals to 6. And decision variables are x, y, s1, s2, a1, all are greater equal 0, and contribution of s1 means slack variable is 0. So we add 0 in 0 s1, 0 into s1 into objective function. Now in second constraint we subtract surplus variable, so we can write plus or minus any, because contribution is 0. So 0 into s2, and last one means we add a artificial variable a1. So for that a1, the objective function is of maximization type, and for maximization we have minus m contribution, and minus m or m quantity represent the larger quantity, means it's infinity. So minus m represent minus infinity, plus m represent the plus infinity. So m is a in short m is a very large quantity. So this is the standard form of given LPP. So take next example. Convert the LPP in standard form, and LPP is maximize z equals to 4x plus 2y plus 3z subject to 2x plus 4z less equal 5. And second constraint is 2x plus 3y plus z greater equal minus 4. So firstly we convert this, because RHS side, third condition of standard form tells us that the RHS constant must be non-negative. For that, firstly we multiply this equation by minus 1, so that we get the constant or RHS constant in positive sign. So we multiply the second constraint by minus 1 on both the sides. We get minus 2x minus 3y minus z, and greater equals converts into the less equal, and minus 4 gets a plus 4. Means our required means our LPP becomes minus 2x minus 3y minus z less equal plus 4. So we have to convert this LPP, remaining LPP in the standard form. So standard form of this LPP is objective function is of maximization type, so we keep it as it is. So maximize z equals to 4x plus 2y plus 3z subject to first constraint. So first constraint is of less equal type, so we add a slack variable on LHS side. We get 2x plus 4z plus s1 equals to 5. And second constraint is also less equal type, because we convert this into this type of constraint. So this is minus 2x minus 3y minus z plus s2 equals to 4. So variables are x, y, z, s1 and s2, all are greater or equal 0. This is the standard form of LPP. Now we take a last example. So question is, write the following LPP in a standard form, and LPP is minimize z equals to 3x plus 4y subject to first constraint. First constraint is x minus y greater or equal 0, means RHS side is negative. We convert this into positive by multiplying minus 1. So this will becomes minus x plus y less equal plus 1, and second constraint is 2x plus 3y less equal 3, and decision variables tells us that the x variable is non-negative but y is unrestricted, means we cannot determine the y is positive or negative. In that case we put y as, so let y can be represented as y dash minus y double dash. I already tell that if y is minus 5, so we can express y as 10 minus 15. So y dash is 10 and y double dash is 15. So y dash and y double dash both are positive. So we can express this y into y dash minus y double dash. So our LPP becomes, so LPP is, so our LPP becomes minimize z equals to 3x plus 4y, y is y dash minus y double dash subject to first constraint. First constraint is minus x plus y, but y is y dash minus y double dash less equal 1. Third constraint is 2x plus y is y dash minus y double dash less equal 3. So this is LPP after converting the these non-negative conditions. So we have to convert this LPP in standard form. So standard form of LPP is so first condition is our objective function should be in maximization or minimization type. So it's already in minimization type. So minimize z equals to 3x plus 4y dash minus 4y double dash. Subject to first constraint. First constraint is of less equal type, so we add a slack variable on LHS side. We get minus x plus y dash minus y double dash plus s1 equals to 1. And second constraint becomes 2x plus y dash minus y double dash plus s2 equals to 3. So our decision variables will be x, y dash, y double dash, s1 and s2 all are greater equal 0. So s1, s2 are slack variable, they contributes 0 in an objective function. So this is 0 s1 plus 0 s2. So this is required standard form of our LPP. I hope you will understand all these topics or all these examples taken in this video. If any doubt, comment in the comment box. Thank you for watching this video.